All right, so let's look at going over this one. How many would bet me a nickel on this one that you got it right?
Well, I don't know anymore.
Well, I mean, you don't know what the right, I mean, yours are better than mine.
Yeah.
Okay, I mean, I just typed it in my calculator wrong, so. First thing we have to do is write a balanced equation. So we have silver nitrate. And that's going to be an aqueous because we're putting it into 50 milliliters of water and it's a nitrate, so we know it's going to dissolve. Okay? So it's going to be aqueous plus potassium chromate, aqueous. And what will that make? Potassium nitrate. And what's the formula of potassium nitrate going to be? KNO3, because K is +1 and nitrate is -1. So it's just KNO3. Since an alkali metal and a nitrate, we know it's aqueous. And the other product? Silver chromate. What's the charge on silver? +1. Now you can look on the periodic table and see there's a little 1 on the periodic table that you have. Or you know it's in family 11, it's going to be a +1. It's also just a good one to learn, or you can look up here on the chart and see that silver says Ag +1. So since it's +1, and because potassium's +1, what must be the charge on chromate? 2 minus. Okay? So therefore it's going to be Ag2CrO4. Since this one's aqueous, if we have a chemical reaction, which we're assuming we do, this has to be the solid. Okay? That's step 1. Now we got to balance it. 2 and a 2. That's the end of step 1. Now, what's next? Find the limiting reactant. Convert each of the givens to moles. So I know that I have a new red pen. Red pen anywhere in here? Purple, purple, blue. Empty box of purple. Nope. I gotta order some other colors. Okay, so silver nitrate. I have 15 grams of silver nitrate. I have 50 milliliters of 0.5 molar. So I want to convert that then. So I'm going to say 15 grams silver nitrate times 1 mole over the molar mass of 169.9 grams. And I plugged this into my calculator completely wrong. So I don't have an answer, so the answer is 0.08 something? 0.0883 moles of silver nitrate. But there's a 2 here, so we would divide this by 2 just for the ratio, 0.04415. Okay? Now we do the same thing, but this time I have milliliters, so how do I convert that to molarity? I mean, how do I convert that to moles?
Molarity.
With a molarity. Okay? 0.0500 liters of K2CrO4 times 0.5 moles for every 1 liter. So we're going to get 0.0025? Just 1 0? Moles of potassium chromate. Okay? So 0.025, 0.044, which one's my limiting reactant? Okay, so this is my limiting reactant. Okay? Alright, so again, aqueous here, aqueous there. The only thing, what's the one ion that's going to change? Given the fact that this is my limiting reactant, what's the one ion that's going to, is there going to be any chromate left over? No. There will be potassium still in solution because it's aqueous here. So which one of these is going to change? The silver. Okay? The potassiums and the nitrates are gonna stay the same. Whatever you put in, that's how much is gonna be there at the end, because none of it precipitated out. Okay? We're not gonna have any chromate left because it's all over there, it's limiting reactant. But we are gonna have some excess silver. Okay? So we can go and we can do the potassium. Well, how much potassium? Well, I have potassium chromate. I know that I have 0.0250 moles of potassium chromate. So how many moles of potassium am I gonna have?
0.0.
Okay, I'm gonna just go and just be very, I'm gonna say 2 moles K plus for every 1 mole K2CrO4. So that's gonna give me 0.0500 moles of K plus. Okay, that's part of the tricky part, is not realizing that with the subscript you gotta multiply it by 2. So my K plus concentration is gonna equal 0.0500 moles of K plus divided by the volume, 0.0500 liters. We can do that math in our head. 1 molar K plus. I don't like that one. Okay? We good on that?
Yeah.
So what do we do then for the nitrate? Because 15 grams here, we divided this, and so it's 1 to 1. For every silver nitrate that we have, we only have 1 nitrate. So however many moles of silver nitrate we have, that's how many moles of nitrate that we had, which is the 0.0883. So we don't have to do anything here. Divided by the 0.050 liters. And this turns out to equal 1.77 molar NO3 minus. Okay, so those are the 2 easy ones. The only hard part about the potassium is remembering to multiply it by 2. Okay, and hopefully this makes it make more sense when you can see it this way. So now what do we do with the silver? Find how much got used. I heard that kind of triphonic here. Okay, 3 people. So for the silver, I'm just gonna start with my limiting reactant, which is the potassium chromate. So I have 0.0250 moles potassium chromate times the ratio, which is gonna be 2 to 1. K2CrO4. Okay? So obviously I'm multiplying by 2, so it's going to equal 0.050 moles of AgNO3 used. Right? Well, how many moles of silver nitrate do I start with? 0.0883. So my excess 0.0883 minus the 0.050 is equal to 0.0383. Okay, we may have to move the camera, I'm not sure, that might show. Okay, so then finally, my silver ion concentration, I'm just going to come back up here. My silver ion concentration is going to be, this is how much is left over. Divided by my volume. And that turns out to equal 0.766.
Good job, man.
All right? Practice makes perfect. Uh-huh.
It requires a lot of brain power.
That's the whole point of AP Chemistry, okay, is to teach you how to think. Okay, because people ask me all the time, Mr. Hobbs, when am I gonna use this in real life? And the answer is very simple, never. Okay? Never. But we're not here, I mean, chemistry is just so doggone interesting on how the whole world works. But you can be very successful without understanding chemistry. But what chemistry, AP Chemistry especially, does for you is it teaches you how to take complicated, bunch of numbers, okay, things that you've never seen before, analyze them, organize them, and then use them to solve a problem. That process is called thinking, okay? So think about the football players. They're in the weight room bench pressing, and it's big, macho, you know, I blew my shoulder out trying to be macho and, you know, see how much you can lift, okay?
Right on the whiteboard last year, who's it?
Yeah, well, I've had 3 surgeries on this shoulder and it's still unfixable, so now they say I need a shoulder replacement, but I'm just gonna play tennis until I can't play anymore and just live with it. But anyway, the whole point is they're in there bench pressing. Have you ever seen them on the football field bench press somebody? No. But what they're doing is in the weight room, they're getting their muscles ready for whatever task they have to do on the football field. We're doing the same thing with our brains in here. We're exercising. We're in the brain weight room right now, and we're just teaching ourselves how to think. We're stretching, a lot of brain power. Okay, we're getting a little tired in our brain. You get tired after working out. But what it's doing is it's training your brain how to think and how to analyze. And that thinking process, when you then get a job, then you get inundated with all this new material. You know how to handle it. You can organize it. You can then use it to solve problems and make money for the company, and they like you. Okay? That's what we're doing. We're here working out our brains. Okay? With stuff that's just, you know, fascinating. It's just to understand all this small little atomic world, how things work. What a great way to learn. What a great way to exercise. All right, there's my motivational speech for you on a Friday morning. Okay? Oh, let's go. Go Giants. All right. So, that's the hardest problem. If we can handle that, then you're going to do fine on Monday. Because you're doing stoichiometry, you're doing limiting reactant, you're doing molarity, you're doing it all in this one problem. Okay? We could just throw in a percent yield, figure out how many grams of this got made, and if the student collected whatever, you know, what was the percent yield? All right. What we're doing next is just going to talk about the solution process. Okay? The solution process. And Advite, would you just kind of move that more towards the center again? Actually, let's shoot it over here. Get this part of the board. What I'm about to share with you for the next 30 minutes is not on the test on Monday. This will be beginning our new unit, which is really going to be pretty much chapter 13. We all know that chapter 13 comes after chapter 4. Always. So we're going to talk about the solution process. And I'm going to post these notes for you eventually. Right now, a solution. What would be the definition of a solution? a homogeneous mixture so since it's a mixture, how many things are present? Two or more. Two or more substances. Okay, that's pretty straightforward. And in that you have, we already talked about this, solute plus solvent yields solution. And we remember this with the solute and the solvent. Solute, things being dissolved, solvent, what it's dissolved into. Okay? So, I mean, if you want to define that, solute, substance being dissolved, I'm trying to keep the notes in order, so I'm going ahead and writing down the obvious. The solvent, substance, the solute is dissolved into. Now, oh, I did that backwards. Well, we're going to add in. There are two types of solutes. See, I should have done that under solute, but oh well. Okay? We can have an electrolyte and a non-electrolyte. Okay? What does an electrolyte mean? It dissolves with a charged particle, and so what does that allow the solution to do? Conduct electricity, okay? It's a substance whose water solution conducts electricity. So I have a light bulb right here, but it's not on. Why not?
Because the circuit's not connected.
Circuit's not connected. If I take this, now this is totally unsafe, I kind of made it this way. So I do not, I'm a trained professional, do not attempt this at home, okay? But if I put a piece of metal between those two and then plug it in, now the light bulb comes on, okay? Because I've completed the circuit. So as long as there's an open circuit, I always gotta make sure I unplug it before I grab that. Otherwise, I complete the circuit. So, been there, done that. It's not a good thing. So, if I put a solution in there, okay? If I take, well, this is alcohol. That's not going to work. Do I have a solution here that will work? Okay. Take a pause.
Let's see who's the best conductor.
Every now and then I'll win.
Do it. Oh, you're an atheist, man. You'll get wrecked.
Wait, so what is an electrolyte?
It's the stuff in your Gatorade.
I know that.
Does that mean
All of the
Gatorade may
nuclear
be
power plant
electric?
stuff. Oh, God.
Yeah.
Bro, if that's on the quest, I'm literally just gonna say,
It's
what's in my Gatorade.
Gatorade
You
may
can
be
draw it
electric.
500 times, I still don't remember.
this has been a fun class. It's
How do
just
you-
so long.
Like, do you know the alpha particles to
Let's
the
put
light?
Gatorade on there and see what happens.
The light? The alpha particles.
Down.
and everything.
Cool.
I don't even
Jimmy,
know.
is it lonely back there?
See, now that you remember the proton.
Is it lonely back there?
I don't even
Got my
know.
best buddy.
I should have planned ahead.
You get me.
Oh, crap. One last thing.
Well, ask him if I can go be the
I just don't
conductor.
understand.
I guess it would result.
Year between taking everything. I would die.
You tell
Very
him.
good.
Oh, wow. He says I can't do that.
Yeah, you do it right now.
Sad that I can't.
That's why why don't you do it?
So,
They don't have to do.
if I take a beaker, this is distilled water. What does distilled water mean? This is flashback from last chapter. It's purified. Well, how is it purified? By distillation, okay, which means we do what? Boil it, distill it. Keep defining it with the same word. Distilled water is made by distillation. Well, how do we do that? We distill it. Yeah, we got work to do in here. So you evaporate the water off, leave the impurities behind, then recollect the steam and condense it back into the pure water. Okay? So this is pure water. Contrary to popular belief, it is plugged in. Pure water does not conduct electricity. Okay? Pure water does not. But I take tap water.
That's crazy.
So what does that mean? That means there are ions in this solution. But what do they use to purify water?
Let's see if that matches
Do what? They filter it, but they also add something to it. Which ions? But since it conducts, it had to be an ion. Okay? Fluoride, they do add some fluoride in some places, and I'm not sure if Birmingham does or not, because that helps with your teeth. Okay, and so fluoridated water, you have much better, many fewer cavities if you have fluoridated water. Okay, now I'm going to take some salt, NaCl. What type of compound is NaCl? It's ionic. Okay, so if I just put some salt into here, stir it up. Voila, the light bulb comes on. So what does that mean present in the solution? It's an electrolyte. It's a substance whose water solution, SOL prospe in a solution, conducts electricity. Okay, so now underneath this, we obviously need to define electricity. Okay, what would be a definition of electricity?
Nothing of electron.
The flow, I heard somebody say a flow of electrons, but it doesn't necessarily just have to be electrons. It's a flow of charged particles.
She's on it for that.
That's right. I know this stuff, something else.
Well, I also stressed that big time in my class last year. Okay? Electricity is the flow of charged particles. Salt in the solid state does not conduct electricity. We have charged particles. You have Na pluses and Cl minuses. But what can't they do in the solid state? Move, flow. Okay? So even though the charge hits it, the ions can't move down the wire, they can't let the electricity flow down because they can't move. But when you put them into water, they dissociate, they break apart into the individual ions, they get the mobility, so when you melt them or you dissolve them, ionic compounds will conduct electricity, the flow of charged particles. So for electricity to be conducted, you have to have charged particles that can move. Now in a wire, does anybody remember metallic bonding? What's the key phrase in metallic bonding? C of free floating electrons. So you have electrons, charged particles, that can flow, so metals conduct electricity. Okay, that's what we normally think of for electricity because wires are made out of metal and that's electrons flowing. But solutions conduct because they have ions in them. Okay, so In order for a solution to conduct electricity, it must contain ions. So this is B, underneath this. In order for a solution to conduct electricity, it must, do I need a comma? It must contain ions. Okay? Now, there are three types of electrolytes. I know I'm probably supposed to go to an I somewhere in here, but I think I'm just going to go back to a 1 and just don't turn me into the outline police or Miss Love.
I got an experience.
Mr. Hobbs doesn't know how to do an outline for the life of him. That's why I teach chemistry now. All right. And when I shouldn't confess this, but when I did all my English papers, I always wrote the paper and then did the outline afterwards. I never was good at doing an outline and then writing. I needed to write. Anyway, so.
Okay.
Yeah. Okay? So the first one are soluble ionic compounds. Obviously they have to be soluble. We just talked about if they're precipitate, they're just going to sit at the bottom, not dissociate, not produce any ions in solution. So soluble ionic compounds. Okay? And these are called, in general, these are called salts. Okay? So they dissolve, what is it, ionic compounds always and can only dissolve as ions. And this is what we were just measuring, always and can only dissolve as ions. Trying to make a point. Real deep. Since ionic compounds are composed of ions, when they dissolve as ions. Okay? So they just break down. So soluble, this is a soluble ionic compound, salt. Okay? So when it dissolves, okay, it dissolves as ions, Na plus and Cl minus. So everything we were talking about in all the previous problems, what are the concentration of the ions in solution? They're all ionic, soluble ionic compounds that are dissociating, breaking apart, dissolving as ions, so they would all be electrolytes. Okay? Now a second type of electrolyte, okay, are going to be bases. Okay? What ion is present in a base?
Hydroxide.
Okay, hydroxide, so it's a metal cation plus OH minus. Now, we have strong bases and weak bases. What do you think is the difference? pH level, okay, but what the amount of OH minus is what's going to determine the pH, okay? So, I'm just getting the words exactly right. These are strong electrolytes. Because they produce a high concentration of ions in solution. Now, there are only 7, I gotta keep going down here. Only 7 strong bases. LiOH, NaOH, KOH, RbOH, CSOH, SrOH2, and BaOH2. All right. So, only 7 strong bases. Now, how do you know that they're the 7 strong bases? It's the alkali metals. Remember, alkali means basic. So, it's going to make a block B on your periodic table. If you come down the alkali metals and then go to strontium and barium right here, you have a block lowercase b. That's your 7 strong bases. All your alkali metal hydroxides, now we leave off francium for 2 reasons. At any point in the world, there are only going to be probably less than 1 gram of francium present. Francium is the result of radioactive decay of other elements, and the half-life of francium is on the order of like 20 seconds. Actually, I think it's 20 minutes. Okay? So, after 20 minutes, however much francium got made, half of it's gone. After another 20 minutes, another half of it's gone. After another 20 minutes, another half of it's gone. So in other words, it's just not around for long. Okay, so other materials are constantly making it, but it's constantly breaking down into other things. So there's not much francium in the world, so we don't even really include it. Secondly, it's radioactive, so it doesn't play well with others, and so we exclude it as well. Okay? It probably has COVID too, because you know that's another reason why you got to be quarantined and not go with anybody. But that's a whole new thing. Okay? So these 7 are soluble in water. So as a result, they dissolve completely. Now, if you go up here and look on that chart on the back, okay, you can see cations of column 1 and barium and strontium are soluble. All other cations are insoluble. So most hydroxides are insoluble. Okay? So only those 7 hydroxides are going to really dissolve, plus ammonium hydroxide, but that really comes from ammonia, and we don't get a large concentration of ions from that. Okay? So those are the only ones that are soluble. All other hydroxides are insoluble or only slightly soluble, so they're going to be called weak bases. Or they're really not even, if they're insoluble, this is 2 under this. All other hydroxides are insoluble in water. Therefore, 3 dots in a triangle is therefore they are not electrolytes. Okay, they're just going to be sitting at the bottom, not dissolved. But we can also have weak, well, how do I do that? Weak bases, 2, B. Oh, I should have brought one. Okay? These are weak electrolytes because they only produce a small number of ions in solution. They still produce ions, but only a few. Okay, now we're going to study this at the very end of the year in great detail. These are very difficult to recognize. because they don't contain the hydroxide ion. They don't contain the hydroxide ion. But instead react with H2O to produce the OH minus ion in solution. Okay? So in other words, you're not going to look at a compound and say it's got an OH in it. You look at it and you have to know that it's going to react with water. Now, those of you that have taken AP biology, you've learned about amines, right?
Yeah.
Okay? And they say it's an amino world out there. Okay? It's a little bit of a science joke. Okay? I told this one yesterday. I said, two atoms were walking down the street, and one said, "Oh man, I think I lost an electron." And the other one says, "Are you sure?" And he says, "Yeah, I'm positive." And so,
That was pretty good.
yeah, that's a good one, isn't it? Okay, just, get good chemistry humor. All right, but they're hard to recognize. They don't contain the hydroxide ion. We're going to study this a lot more, but amines contain nitrogen. Nitrogen-containing compounds tend to react with the water to produce, okay? Okay, so examples would be something like NH3, ammonia. You bubble ammonia gas into water, and I'm going to write water as an HOH. And it's going to make NH4 plus OH minus. And that's what we talk about ammonium hydroxide. But this is a reversible reaction, and only about 1% of all the molecules that you dissolve actually react with the water. 99% of them dissolve as neutral molecules. Okay? But only a small fraction actually react. So if we took an amine such as, we can say dimethylamine, CH3, N, okay, H. That looks like that. You put it with water, it's going to do the same thing. You're going to end up getting CH3, H plus, and H, plus an OH minus. This whole thing is positive. You have the plus charge right there, but this whole thing is positive. So anytime you have a nitrogen, now again, very hard to recognize. You are not going to be expected to recognize these on this particular unit. We're going to wait until we get to acids and bases to really look at weak bases and how they operate and being able to recognize them. But just to introduce the concept, bases are electrolytes, but we have strong bases, we have weak bases. Strong bases are the ones we're pretty much going to deal with. The alkali metal hydroxides, barium and strontium. So again, if I take, rinse this out, get all the salt out of it. If I take a base, such as NaOH, a strong base, what do you expect as far as conducting electricity? It should conduct electricity, and voila, it does. It's a strong base, it conducts well. But if I brought some ammonia in here, which I should have brought some, but I didn't. If I brought some ammonia, this is that. Ammonia's a weak base. So the light bulb comes on, but barely, it's dim. Because it still conducts electricity, but just not as well, because there aren't as many ions. More ions that are present, the better it conducts. Okay? Now, we're running out of time, so I'm going to kind of stop right there. But what would be the third type of electrolyte? Okay? You got a soluble ionic compound, salts. You got bases. Acids. Okay? Acids. Okay? So I'm going to write all this. I'll do this tomorrow. But I'm just kind of letting you know. Okay? And again, I have all this, and I'll post all these for you, but I think it's good for you to kind of write them down too.
Yeah.
Okay? Well, I hope y'all have a great weekend,
Hope so too.
okay? Study if you think you need to for the quiz. Hopefully all these practice problems make you feel like you're pretty much ready. And pray that I have a productive weekend painting in my kitchen, in my house, so I can get a kitchen back. I've been without a kitchen for 2 weeks now, and I've got another 2 or 3 weeks.
Oh, that sucks.
Yeah, I mean, nothing, no appliances, no sink, no cabinets, nothing.
Did I haven't used my kitchen in like a month.